Good day and welcome back for part 2 of our discussion on substitution. Substitution is a technique of integration which undoes the chain rule of differentiation. And as a reminder, when it comes to integration, as a student in Calculus 1, you are in a fantastic position. We essentially have two approaches. We look at our integrand function and we can either directly or through algebraic manipulation break it down and compare it with our common indefinite integral formulas. Or we will attempt to use a substitution. Now, when using a substitution, you need to come up with a choice of u, which is typically going to correspond to an inside function, usually the largest possible inside function we can find. So if u is equal to g of x in this case, remember how we calculate du. It's g prime x, the derivative of that function g, times d of x. So we start off with an integral that involves all x's and is complicated or difficult for us to evaluate. Once we do the substitution, it now only involves the variable u, and it's hopefully a simpler integral, easier for us to evaluate. That is the goal. So with that in mind, let's go ahead and explore a few more examples. And let's start off with the indefinite integral of 3x times cosine of 1 minus x squared. And our intuition is the same as it was before. I have no idea how to integrate this in its current form, but note we do have this inside function, 1 minus x squared, and up to a constant, its derivative appears outside of the cosine. So this is an indicator that we should try substitution. If u is 1 minus x squared, du is minus 2x dx. And we need to go from all x to all u. So clearly by the choice of our substitution, 1 minus x squared becomes a u. That leaves us with the 3x dx that somehow needs to be accounted for by the du. And note, we have an x dx that we can take care of with the du, which guides our approach. 3 is a constant. We'll pull that in front of the integral. That leaves us with an x dx, and note minus 1/2 du would be equal to x dx. So we can go from all u to all x. So the 3 gets pulled out front. We have cosine of u, and then the x dx is a minus 1/2 du. And I'm going to go ahead and leave the minus 1/2 in just so we see precisely where each term is gone, but you just as easily could have immediately pulled that 1/2 out front as a constant. So minus 3/2, the indefinite integral of cosine. So note, all u's, and certainly much easier for us to evaluate. The antiderivative of cosine is sine, so minus 3/2 sine of u plus c. And remember, when evaluating an indefinite integral with a substitution, our final step is always to resubstitute. So minus 3/2 sine of 1 minus x squared plus c. And when using a substitution, this is essentially what your work should look like. A nice vertically aligned column using proper notation. It's an indefinite integral, so we include that plus c. And we have placed this work with indicating our choice of u and du to the side so that it does not interrupt the flow of our work. And we're going to finish this video up with one additional example. We're going to integrate this using substitution, but it's going to involve a slightly different technique. And just to get the wheels turning a bit, I would like you to pause the video and give yourself, let's just say maybe 2 or 3 minutes, and see what you can do. My hint is you want to pick u to be inside something. So give that a try and see if we can make it work. So my hint there was to choose or attempt to let u be 2x plus 1. And remember, all we can do is try and see what happens. So if u is 2x plus 1, du is 2 dx. So we can take care of dx, so immediately we have 1/2 du is dx. And we need to go from all x to all u. But note, we have this leftover term. There's this extra x that we have yet to write in terms of u. And whenever that happens, you simply go back to your substitution. After all, the substitution gives you the relationship between x and u. So if you wanted to solve for x, you could write what? U minus 1 is 2x, or u minus 1 over 2 is equal to x. So if we let x be u minus 1 over 2, we can now take our integral only involving x's and rewrite it so it only involves u's. So we have two constants, a 1/2 and a 1/2. I'm going to immediately pull those out front as a quarter. The x still has that u minus 1. We've pulled the 1/2 out. Square root u du. And getting it to this point is really the most difficult step in the problem. And once again, the key observation to emphasize. If you have any leftover variables, in this case the x, we go to our substitution to see how we can rewrite it. Now it becomes an older problem. Can we evaluate this indefinite integral? And it turns out the technique we need here is something we've encountered several times in the past. Algebraically manipulate until we can compare to our table of common formulas. Square root of u is u to the 1/2. If you distribute that u to the 1/2 through, you would have u to the 3/2 minus u to the 1/2. And this is something we can anti-differentiate term by term, and hopefully these antiderivatives are becoming quicker and more efficient the more you practice. So u to the 3/2. 3 plus 1 is 5/2. 1 over 5/2 is 2/5. And similarly, 1/2 plus 1 is 3/2. 1 over 3/2 is 2/3. And because it's an indefinite integral, we have a plus c. And remember this last but very important step. With an indefinite integral, we need to resubstitute to get things back in terms of that original variable x. So simply substituting back in, we will make each u a 2x plus 1. And once you get it into this form, there is certainly a little bit of arithmetic you can do with combining together constants, but I am perfectly all right leaving it in this form. And in our next video, we'll continue on with several more common examples involving substitution and indefinite integrals. But as usual, this is a great opportunity for you all to practice, so make sure you're looking through and working suggested problems. When you have questions, drop me an email or stop by office hours. Stay tuned. Take care.